In today's video, we are going to learn about solutions to a quadratic equation. So before we begin with what a discriminant is, I want to show you the three graphs that you would have to know in order to understand this. First of all, if your graph does not go through the x-axis at all, there are going to be two non-real answers, and again, meaning imaginary. So b squared minus 4ac is going to be less than 0. Okay? And then you're going to basically get a negative number on the inside of the radical. Okay? The next one, you'll notice it goes through two places on the x-axis. That is considered two real answers. And that means that b squared minus 4ac had to be greater than 0. So there was a positive number inside of the radical. And then for the last one, if it hits only once on the x-axis, that means that there is only one real number, and that b squared minus 4ac had to equal 0. And underneath the radical, you'll just see a 0. So let's apply that on the discriminant. B squared minus 4ac is the discriminant. Okay? That right there determines what solutions that you're going to get. So just to reemphasize, the b squared minus 4ac, if it's greater, you get two solutions. If it's equal, you get one. And if it's less than, there are no real solutions. They're all going to be imaginary. And maybe add that in would be a good idea. Imaginary answers, or complex. Okay, so let's look at a couple examples here. The first one, we would first need to know what A is, and B is, and C is before we can use the discriminant. And the discriminant is only the b squared minus 4ac. So let's go ahead and plug in some numbers. 6 squared minus 4ac is 36 minus 36 for an answer of 0. So that means that there is one real solution. That means, again, one real means it's going through the x-axis one time. The next one, we have A equaling a negative 16, B is 11, and C is negative 11. And when you plug that into the discriminant, you end up with 11 squared minus 4 times negative 16 times negative 11. And you get 121. I do not know this, so I need to use probably a calculator here. And you end up with 64 times negative 11, and then 121 minus 704 gives you a negative number, because 704 is bigger than the 121. So there's going to be two non-real answers here, or solutions, or roots. Again, imaginary. So that determines those solutions. Go ahead and try the next two, see how many solutions you can get. Push pause on the video. So on the third one, if you have two real, you are correct. And if you had two non-real on the second one, you are also correct. And just to show you a little bit of the work in case you did not get that along the way. So it would be 121 minus 4 times A times C. And then when you put all that together, 121 plus 96 is a positive number. So that's definitely where the two real will come from. The next one, B, A is 1, B is not there, so we have to put a 0 in for that spot, and then 2, so b squared, so that's 0 squared minus 4 times 1 times 2, 0 minus 8, and negative 8 is a negative number, therefore it's going to be two non-real. Okay, so for the last thing we're going to talk about is how do you set up a quadratic equation whose solution are the following. Okay, we've talked about this a little bit before, so you may feel like you've seen this already in last chapter. Basically, you take the solutions and set them up as factors. Set them equal to x. I should probably do that first, and then have them as factors by setting them equal to 0. Then when you FOIL x squared, outside insides are going to cancel, leaving you with x squared minus 16. So that is going to be the quadratic equation that it's looking for. The next one, if it's negative 5 only. Now this was a little new, but anytime you have a negative 5, there are two of them. So x equals negative 5, and x equals negative 5. It just means it's going to repeat. So you have x plus 5 here, and then x plus 5 on this one as a factor, and we're going to multiply them together. And once again, there's your quadratic. Okay, the next one gets a little trickier just because it has a fraction, and if we set this equal to x for both of them, it's just doing some math operations. So if I multiply both by 4, we can get rid of the fraction. On this one, multiplying both sides by 2, we can get the fraction gone as well. And then setting it equal to 0 on both situations gives you 4x plus 1 equals 0 and 2x plus 1 equals 0. Now we're going to take those two and multiply. Okay, so go ahead and push pause and do so. Okay, so hopefully you end up with 8x squared plus 4x plus 2x to get the inside and outsides, and then plus 1. And then cleaning it all up would be 8x squared plus 6x plus 1 for the quadratic. And then finally, the last one, again, we're keep going up in levels of difficulty here, but do the same exact steps. Set them equal to x. Now set them equal to 0. And now multiply the two of them together. Okay, so it's a little more intense. We have a lot to multiply. X, you're going to multiply by all three in the second trinomial. Same with the negative 1, same with the negative 2. Okay, go ahead and push pause and see how you do. So if you multiply x's together, you end up with x squared negative x and x square root of 2. If you multiply the next one and put that in a different color, negative 1 times x is a negative x. Negative 1 times negative 1 is a positive 1. And negative 1 times square root of 2 is negative square root of 2. Okay, and then in red, let's do the last ones. Here is a negative x square root of 2. Notice I'm putting them right underneath. It just makes it easier for canceling. Negative square root of 2 times negative 1 is a positive square root of 2. And the last one is a negative 2. So that's going to combine with this one. All right. Now, if we add everything we have left over, x squared minus 2x, those cancel. And then minus 1, and those cancel. There is our quadratic. So that definitely is the most difficult of all of them, but I know you can do it. So that concludes this lesson for today.